All right, welcome to chapter 7. It's the, third last chapter? So, this chapter is the chapter on radicals. So, it says roots, radicals, and root functions. So, roots and radicals, same thing. And then the fact that we throw in the word functions means that we're going to be graphing them. So, the first thing we want to look at is just some terminology. So, when you have something that is a radical, it means that you've got this root symbol. Okay, so this entire thing is called a radical, and then there's sort of three parts to it. There's the part that's under the radical sign, so where this A is located, and we call it the radicand. Then we have the number that's going to be written in the little nook of the radical sign, and we call it the index. And then the whole thing is called the radical. We often talk about when we take, when we perform the option or the operation. So for example, this one, the square root of 17, we would say the root of 17 is. So if you wanted to use that language, that's sort of the right place to use it. So the next thing we're going to do, now that we know the parts of a radical, we're going to actually practice making sure that we can do these on a calculator. So the first thing I want to do is just make sure you know where your square root button is. So if you can type into your calculator the square root of 17, and then the other part of this is, can you use the calculator to approximate, which means that we're going to do some rounding. And so we are going to round to 3 decimal places. So on your calculator, you should find that exact button. So for me, I have an x squared button, and everything in the calculator is kind of set up in pairs. So above the square button is a square root sign, but it's written in yellow. So I'm going to type second function x squared. So the yellow button brings up what's written in yellow, so I can take a square root. So the square root of 17 is, I get 4.123. And then the number next to the 3 is a 1, so I'm going to keep the 3 as a 3. I'm just going to make my pen a little bit narrower. Okay, so then the next one we're going to plug in is negative square root of 362. Now the reason I put this question in is because I want to see if you can. Can you type into your calculator negative square root of 362? Because I guarantee you probably can't. There are some calculators that will let you do it, especially one that is okay with the subtraction sign being a negative sign. But for most people, if you try to put negative 362 or negative the square root of 362, oh, mine will let me do it. There we go, proved wrong. So I can hit plus or minus and get the negative, then I can put my square root sign, and then I can type in 362, and then it gives me the answer of negative 19.026. If you can't do that, like if it won't let you put a negative out front, you could put negative 1 times the square root of 362, because that is another way of reading this. Or you can just type in the square root of 362 and then make sure your answer comes out negative. All right, then we get into cubed roots. So for me on my calculator, I have a button above my x cubed button. I have a cubed root of x button. So again, it's written in yellow, so I can do second function cubed root x, or second function of the cube button, and I can take the cubed root of 9,482. So second function cubed root 9482. And then to 3 decimal places, that gives me 21.166. If you do not have a cubed root button, you're going to follow the instructions that I'm going to use to take a fourth root. So our calculator doesn't have a preset fourth root button. So what I'm going to use is a button. Okay, so I have a y to the x button, and above my y to the x button, I have an x root button. So again, you're going to use the second function, but one sec. So the first thing you're going to do is you're going to type in the 4. So I'm going to type in 4, then I'm going to hit second function x root. So now it says 4x root, and then I'm going to type in 6825. And that tells my calculator that the 4 is going in the place that the x is. So I'm going to take a fourth root, and I get 9.0892. So the 9 is going to stay the same. So make sure that you can plug all three of these into your calculator. If my instructions aren't making sense, Google the instructions for your specific calculator. It'll tell you how to plug it in. Awesome. All right, the next thing that we are going to do is just talk about roots and negatives. So for example, if I asked you to find the square root of 4, what would your answer be? Now, can you do these without a calculator? The square root of 4 is 2. And the reason 2 is the root of 4 is because 2 times 2, or 2 squared, is equal to 4. If I asked you to find the square root of negative 4, okay, now this is different than negative square root 4. This time the negative's underneath the square root sign. So if I type second function x squared, or if I just type my square root button, and then I put in negative 4 now, so not negative square root 4, but square root negative 4, what does your calculator say? The calculator says error. And why does the calculator say error? Is because this does not exist. And why doesn't it exist? Well, because negative 2 times negative 2, or negative 2 squared, equals positive 4. There is no way of finding a number that multiplies by itself to give you a negative number. So the square root of negative 4 does not exist. What about the cubed root of 8? Now, hopefully, the reason you don't need a calculator is because the answer to all of these are 2. So the cubed root of 8 is also 2. Why? Because 2 times 2 times 2, or 2 cubed, is 8. So now let's look at the cubed root of negative 8. Is there a cubed root of negative 8? Well, yeah, it's negative 2. So this one does exist because, now I'm going to stop writing out the repeated multiplication. I'm just going to put negative 2 cubed, because negative 2 times negative 2 times negative 2 is negative 8. When you have an odd number of negatives multiplying together, you get a negative answer. Okay, what about the fourth root of 16? Well, the fourth root of 16 is also 2. Why? Because 2 to the 4 is 16. What about the fourth root of negative 16, right? What does your calculator say? What do you think? Well, again, it does not exist. And why does it not exist? Because if we took negative 2 and we multiplied it by itself 4 times, we would get positive 8. All right, last one here. What about the fifth root of 32? Well, again, it's 2. Why? Because 2 to the 5 is 32. And then the fifth root of negative 32 is negative 2. Why? Because it's an odd exponent. Negative 2 to the 5 is negative 32. Oh, look at that. I put positive 8. Sorry. Let's fix that before someone comes at me. 16. Okay, so what can we generalize about this? Well, when the index, the number in the radical symbol, is odd, you can take the root of a negative number, but when the index is even, you cannot. Okay, so that's just something to be aware of. Anytime you have a square root or a fourth root or a sixth root or an eighth root, you won't be able to take the root of the negative number. Whereas if the if the index is odd, you always will be able to. The last thing that we're going to do here is just throw those negatives in again. So just a little bit of practice of thinking about when you can and when you can't. So the difference is if the negative's out front. So negative square root of 25 versus negative the fourth root of negative 16 versus negative the cubed root of negative 27. So that's what Math 50 does to you all the time. It's like throws in negatives to make everything hard. So for this one, can you? It's an even root of a positive number. So you can think of this as negative 1 times the square root of 25. The square root of 25 is 5, so we're good to go. If you want to use a calculator, make sure you can. For this one, we've got the negative times, or negative 1 times the fourth root of negative 16. As soon as I see the even root, then I know that this does not exist. I'm using the terminology does not exist because the answer is actually imaginary. If you go on to Math 60, we will actually have answers for this. But for us right now, we're just going to say, nope, it doesn't exist in the context of what we'll be looking at in further chapters. All right, and then lastly, this one, we've got negative 1 times the cubed root of negative 27. Since it's a cubed root of a negative number, we can do it. If you know the cubed root of negative 27, write it. If not, use your calculator. Right? Do you put the negative sign in? Do you just kind of know that it's going to come out negative? Regardless, the cubed root of negative 27 is negative 3. But we have this negative out front, so it's going to be negative 1 times negative 3, which is going to give me positive 3 as an answer. Okay, so hopefully you're okay with the whole idea of throwing negatives in. And then the last thing we're going to do is throw in some fractions. So what if I have the square root of 16 over 25? Well, the nice thing is you can just do the square root of 16 is 4 over the square root of 25 is 5, because you can do them separately because 4 fifths squared is 16 over 25. So if it was a cubed root, you could do them separately as well. You could do the cubed root of 1 is 1 over the cubed root of 27 is 3. And again, that's because the 1/3 cubed oh geez, would give me 1 over 27. Awesome. So that's the first part. Try to do as much as you can without a calculator, but also try to do them with a calculator. There's a healthy balance in this course of things that you should be able to do mental math and the ability to also use a calculator to get an answer. Good luck.